Welcome friends. So in the last video we talked about what a basic control system is, and we talked about two types of control system. One is the open loop control system, that is the open loop system, and a closed loop system. So first of all, we need to know what the basic aim of a control system is. The basic aim of a control system should be that it should reduce the error such that the value that we get and the value that we desire, there is no difference among that. What we talked about, that the value that we desire and the value that we get, there is an error among it. When there is no error among it, then the control system is perfectly matched. Okay, so now we'll talk about the loop that we talked about, the open loop system and the closed loop system. So what is that actually? Let's talk about the loop part. That is, what is a loop? If we start from a particular point and we move at another particular point in a particular direction and again back to that point, we know that this thing is called a closed loop, right? It's almost similar to what we'll see in a closed loop system, and an open loop is just a forward path. That is, there is no closed thing in it. So this is an open loop, right? So that is what a closed loop and an open loop looks like. So in terms of here, so now I suppose everyone of you know what a transfer function is. A transfer function, a system is, this is a system where we give an input, say xt, and we get an output, say yt. Okay, and there is an impulse response of the system which is ht. So we know that xt convolution of ht, that gives us the yt. Great. So if we move into the Laplace domain, we can see that xs into hs gives us ys, right? So this hs, this is known as the transfer function. We know that. So every control system has a transfer function. Now an open loop transfer function can be like written like this: gs, this is the ys, this is the xs, right? A closed loop transfer function can be written like this: is the gs, and this is the xs, this is the ys, and here will be another return block, that is a feedback block. Okay, this is the feedback block. Right? So this is a closed loop system. This is an open loop system, right? Now, thus we can see that there are two types of system. One is the open loop system and one is the closed loop system. The transfer function of an open loop system is known as open loop transfer function, or from now on we'll call it OLTF. And the transfer function of a closed loop system, that is, if we take this whole as a system, this totally will be called as a transfer function which is called as the closed loop transfer function, that is the CLTF, right? So we can see that we have two types of transfer function, that is the open loop transfer function and the closed loop transfer function, right? So we need to find what is the closed loop transfer function. What will be the closed loop transfer function of this total system? We know if it is an open loop transfer function, then the direct transfer function is gs. But in this case, what can we say the transfer function to be? So that is what we learn in this video. That is how to find out the closed loop transfer function of a particular system. Now let us start with a closed loop system. We see this is my gs. This will be my feedback block, that is my hs, right? There will be obviously a summer out here. Okay, this is plus, this is minus. The input is plus, that is, we say the input is rs, and this is my cs. Rs is the required input and cs is the controlled output. Okay, so and this part that we get, that is rs minus, suppose this is bs, right? So this difference is known as es, that is the error signal. First of all, let's make something clear that what is CS? CS, that is the output. As in the frequency domain, we are directly multiplying this and this, because in frequency domain we know that the transfer function is directly multiplied with the signal. So CS will be directly equal to ES into GS, right? Now let's talk about what ES is. ES, that is the error signal. Error signal is the difference between the signal that we are giving and the signal from this feedback. So the ES is equal to RS minus VS, right? This RS is just written as RS, and VS can be written as CS into HS, right? Because this signal is getting into the transfer function HS and thus becoming BS. So BS is rewritten as CS into HS, right? And now CS can be again rewritten as ES into GS, right? It can be rewritten as ES into GS. So RS minus ES into GS into HS, right? So that's what we are getting. Now if we take this part to this side, to the left hand side, we can take common ES and write as 1 plus GSHS is equal to RS. I hope it's clear with everybody. So we get two equations. One is this one, that is CS is equal to ES into GS, and one is RS is equal to ES into this whole thing. So we know that the transfer, what is the transfer function? It is the transfer function is equal to the output by the input in the frequency domain or in the S domain. So the transfer function is directly equal to the CS by RS, right? So we can write the CS as ES into GS from equation number 1, ES into GS, and the output, that is RS, we can write it as ES into 1 plus GS HS, right? So the ES gets cancelled, and thus we get the transfer function of a closed loop system is equal to GS by 1 plus GS HS. So this is the formula of closed loop transfer function that you guys need to remember. That is, the transfer function of a closed loop system is equal to the GS by 1 plus GSHS, where GS is the forward block and HS is a feedback block. So in this video we learned how to calculate the transfer function of a closed loop system. In the next video we will be learning on how to deal with problems or how to plot the pole zero map of a transfer function. Thank you for watching.